Okay, last section, radioactivity. I think this would be strong for lots of you really, because you don't have any nuclear fission or fusion in there, which will be a bit of a bonus for some of you. Oh, I've had a little mare there. I've pressed loads of buttons when I shouldn't. Let me just get rid. So the first part, describe the structure and properties of alpha. Explain why alpha has the highest ionization levels and presents, there should be an S there, the highest risk as a contaminant. Now we're going to get a mark for just saying a contaminant is when a source is in or on you. So now let's describe the structure. It's made of 2 protons and 2 neutrons. It's a fast, large, positive particle with lots of momentum. Mass times velocity. So it's great at knocking electrons from atoms. So that's the crucial part. We've now explained why ionizes atoms. Because 2 protons and 2 neutrons, it's a fast, large particle, and it's got lots of momentum, so it can knock electrons out. And then now we've got to say, well, why is it the biggest risk as a contaminant? Well, it's got a short range, so its only risk is when it's in or on you. So it's the most ionizing, and the risk is when it's in or on you, because it can't go very far. Okay, next part. What is background radiation? How can it be calculated? So background radiation is radioactivity in the environment from rocks and air, etc., etc., etc. We could say that we've got natural sources, like the rocks and the air, and artificial nuclear reactors, but we're just going to go with radioactivity in the environment from rocks and air. First job, let's get a Geiger counter, the thing to measure it. Next bit, let's make sure there are no sources near at all, because otherwise it's just not going to work. I don't even want to have a banana that's slightly more radioactive near me. Measure the counts over a minute. Repeat 3 times for the mean, and then we'll have the counts per minute for background. Next one I'm going to draw out. It says describe the radioactivity penetration test for alpha, beta and gamma. So I've got a mark for saying I need a Geiger counter. Now I'm going to get my source. All right. And then I'm going to have a small gap here, only because if it was, let's say, if it was larger than 2 centimeters, alpha can't make it. So I've got a small little gap in between. Now, I'm now going to just say what I've got in between. So it's a small gap. Okay. First paper, this stops alpha. Next part, thin metal, 2 millimeters. This stops beta. Thick lead. This stops gamma. And I think you'll ace that. All right. Now just be careful with your wording. Okay, next one. Almost at the end. What is the time required for a source with a half-life of 2.5 days to decay from 400 sieverts to 50 sieverts? So we know we take 400, right, start underneath. Half it, half it, half it. We've got to 50. That is 3 half-lives, and each one is 2.5 days. 3 times 2.5 equals 7.5 days. Next one, use the graph to calculate the half-life. So start at 140, find 70, read it down, and I get 1.5 minutes. Next one, why are radioisotopes used as medical tracers? Why are they made immediately prior to use rather than being stored? So we've got a mark, they have short half-lives, and then the next part is to just say, and we need them to have some activity by the time they go in the patient. So here's my answer. So they need to be quickly used so there is enough radioactivity to detect. And I'm now just giving you the answers to the other bits. Now we've got to complete the nuclear decay equations. So you need to know alpha is a 4,2. We're then going to, all of this side has to equal this side, because obviously there's our chemical reaction sign, or product of sign. So 95 take away 2 is 93. 240 take away 4 is 236. You will ace this. Next one, we now need to have the beta, and it wants minus. So -1, 0. And again, something -1 has to be 90. Well, that must be 91. Why have I left that as 94? Ignore. So, no, that. I've used the Neptunian one. That's going to be 91. Pretend you didn't see that. Nothing to see here. Never happened. That was not a mistake at all. So 91 take away 1 is 90. And then 2, 2, 3, 2. And I actually copied and pasted it and then added 1. Right, hopefully that helps, apart from me making a complete and utter pig's ear of the last one. But good luck, guys. Remember, do not just watch the videos. You've got to sit down and practice and write these things out. Thank you all, bye.